Hello everyone, today we'll talk about the problem time needed to buy tickets. In this problem we are asked to imagine a situation where there is a queue of people who want to buy some tickets. And everybody wants to buy a certain number of tickets. However, every person can only buy one ticket at a time, and when they buy that single ticket, if they want some more tickets, then they have to go to the back of the queue, wait for everybody else to buy their ticket, and then they can buy another one. So they will cycle through the queue. At different points some people will leave the queue because they are satisfied with their number of tickets. And we are asked how many steps are necessary for the person at a given position K in the original queue to finish buying all their tickets. This problem is classified as LeetCode easy, so we can correctly assume that it's possible to just simulate this situation, but of course we want to talk about a better solution, specifically a solution that's linear with respect to the number of people in our queue and doesn't depend on the magnitude of tickets of I, such that even if people were, let's say, trying to buy 10 to the 9 tickets each, then you can just quickly simulate this process and not in a way that doesn't really depend on the exact magnitude. Probably the easiest way to think about this process is to consider full cyclings of the queue and imagining how many of those cycles will happen and how they will influence the amount of time spent by the person on our position K before they finish buying all their tickets. Because we can see that, let's say we have an original queue and our person is here. Then after a full cycle, everybody here would have bought a single ticket. This person would have bought a ticket. If that was the last ticket they wanted, that's the end. Otherwise, all these people have to buy their tickets. And this becomes our new queue. And now perhaps this part is shorter, perhaps this part is also shorter. And we're here wanting to buy one fewer ticket. Luckily for us, doing it quickly is actually not difficult. For instance, if everybody besides our person, let's say they wanted to buy more tickets than this person, then for our person K to buy K tickets, all of those would have to buy K tickets, and all of those would have to buy K minus 1 tickets, right? Because after the final cycle, we don't have to care about them. This person leaves the queue, and that's the point that we're interested in. And now, if some of these people want to buy fewer tickets than K, then it's not really a problem. That person just, instead of buying K tickets, buys the number of tickets that they want, and then we don't care about them, they're not in the queue anymore. And with that in mind, we can essentially just return the answer, because it's for everybody who's in the queue before our person, that's just either K or the number of tickets they want, the minimum of that. For everybody after our person, that's the same, but K minus 1, because we know that we're going to buy one ticket before we get to the back of the queue. And that's exactly what we're doing in code. So essentially we calculate the minimum of the number of tickets a person wants and the number of tickets the cave person wants. The same thing after the cave position, but of course now with one fewer. The sum of that is our result and we just return it.